I have a number of things to cover with you. We're going to go through it very quickly to make sure that we are within the time prescribed. I was warned about that, not to go over. So first, just by way of introduction, I'd like to tell you who I am and what I do. So I run a software testing and automation company in the Washington, D.C. area called ALP International, ALPI for short. I'm also a volunteer on the ASTQB, that's the American Software Testing Board. Much like you have the Hungarian board, we have the American board that serves the US. And I'm also the working group chair for the advanced level test automation engineer syllabus working group. That's an effort that's been in the making for many years. And I'm actually very pleased to say that we're here gathered together on a very timely basis. Only last Friday was the document, the syllabus called Certified Tester Advanced Level Test Automation Engineer. It was approved for release. I have a copy. I have proof right here. If you'd like to come look at it, this is a display copy. Please do not take it with you. If you'd like a copy, I'm happy to either send you one. I'll have some cards here, or it'll be able to be downloaded in short order from the ISTQB site. So that's by way of introduction. Go past that. A little bit about background. Everybody comes from a different background, why they're here. With that background means that we have baggage. What does that mean? It means that we all come with ideas about things, of how things should be done. Sometimes those work very well. Sometimes they're contrary to what we're trying to do. With the baggage come also expectations. What are our expectations about automation, and how can we make sure that they're realistic? So, from my own experience, I'd like to say that I got involved early on out of necessity. Basically, I was on a project where they were converting from an old financial system to a new financial system. And I was the lone tester, the sole tester, and I had to find a way to be very efficient and effective at what I was doing. There's people that understood the finance. That was not me. So what I realized was that I needed some way to translate the information that the business analysts knew into automation, and that was kind of the beginning for me of automated frameworks. That then became a way of doing business and became part of an ongoing solution that we find actually helps us quite a bit, and it also helps the customer. So we've all seen this expression, necessity is the mother of invention. What does it mean? It basically means that when you're up against the challenge, you really need to figure out how to do something. And that's kind of sometimes where we get our most creative moments. So when we talk about automation, there's kind of a life cycle of what we see people using automation. Initially, everybody's very excited. There's been budget approval to buy tools, to get the project started, so everybody's all very gung-ho. Then, you get the tools. Some of them have, a lot of functionality, a lot of programming code behind them, so it's a little confusing to figure out how to use them and what to do. Then you become possibly a little frustrated because all of a sudden the tools aren't really doing some of the simple things that you expected them to do. Then in the middle years, you're chugging along, you're writing some scripts, you're running some scripts, but then all of a sudden, the simplest scripts that should run as part of your regression stop running. There goes that opportunity to leave early on the Friday to go to the beach or to the mountains. Just not going to happen because you just are fearful that the automation will stop an hour after you leave, and then what? So automation can become all-consuming. It can become a project in and of itself, and often what I find is that people end up creating code that's almost more complex than the application you're trying to test. So clearly a step in the wrong direction. In the late years, what we find is that you're working very hard to update the automation, to run those regression tests, and then you find out, oops, the application has already been released. Oh my gosh, that doesn't make you feel very good. You feel disillusioned, like nobody really cares anymore about what you're doing, and guess what? You just decide to abandon the automation project, look for some other project, maybe some web development, and then you wonder, did anybody even notice? Now, unfortunately, this is both funny and sad because this does happen, and it happens all too often. So let's figure out how we can get around that. The next phrase that I want to talk to you about is what's in a name? That which we call a rose by any other name would smell as sweet. Does that sound familiar? In the US, everybody knows what that is. Who wrote that? William Shakespeare, okay? Many of you may know who he is. Famous line, but the point of the line is you can call things different things, but sometimes they all mean the same or they mean different things. So terminology is very important to know what we're doing with test automation and automated frameworks. Automation and testing, that's a big one right there. Automation is not testing. Automation is a mechanization process. What's a framework? We'll talk about that shortly. What are the different roles that need to be involved in a framework development? And what type of frameworks are there? So is a framework scripts? Is it an architecture? Is it a set of functions or libraries? Is it all of those? Is it none of those? Well, if we look at the definition of the word framework, we see that a framework is an essential supporting structure of an object or a basic structure underlying a system. Now, this definition clearly has nothing to do with automated frameworks, but it has everything to do with automated frameworks, because when you build an automated framework, what you want is to have a foundation to your automation. You want something that's rock solid, like the foundation of a house or a building, like the pillars of a bridge. You want to make sure that that automation foundation helps you build and is rock solid, is not going to break, and is going to sustain what you build on top of that. That's how you have to think about when you build an automated framework. So there's many types of automated frameworks, and I'm going to discuss three families of them: data-driven, keyword-driven, and process-driven. You may have other names for them, that's fine, but as you'll see, they all essentially drive data through a system. So to a certain degree, they're all data-driven. So let's talk about the most basic data-driven framework. It's the least complex to implement. It combines both static and dynamic elements, and for maintenance, it's very high. Why? Because you have a script on your left here. The script basically has hard-coded functionality, hard-coded navigation through your application. And really what you're doing in the most basic data-driven script is you're substituting those hard-coded values that were captured initially with variables so that you can then create a test case or several test cases that have several conditions for customer number, for order number, so you can test out your system and see if it works. So that, at a very basic level, is a framework, a data-driven framework. It does work. It's easy to add additional data paths to it, but it does have some challenges when you need to change things around. Next, we'll talk about keyword-driven. So with keyword-driven, it's a little more friendly to look at. You know, you're looking at a set of conditions. You need to buy and sell securities. You need to buy them at a certain price, certain quantity, so you can lay that all out in a very nice table. So in terms of developing a test script, it's very easy because you don't really need that technical knowledge. Where the difficulty comes in is to have the code on the back end that interprets that information and figures out how to use that information. So we may have a routine, which is our buy-sell script, and based on whether or not the action is to buy or to sell, it'll automatically then call an action to buy or to sell, and then from there, it'll place the parameters into those variables to execute that particular transaction. So it's nicer on the front end from the test case standpoint, but on the back end, we still have kind of the static navigation and some variabilization. The keyword-driven framework has a high degree of encapsulation. It's extremely easy for the test scripts to be developed, and the degree of maintenance is actually medium to high because it does have that static component to it. And also, it has what I call low auditability. What does that mean? That means that if you're trying to figure out what did my script actually do when it ran, you don't have a lot of evidence. You know, you have a table that shows this is the conditions we're testing, and then you have all this code that's doing who knows what, but it's harder to see exactly what happened or what didn't happen. And by didn't happen, I mean, what about a verification point that you planned on having in there? Maybe the verification never occurred. Maybe there was a comment in the code. It makes it difficult to find out whether or not you did that or you didn't do that. Which brings us to process-driven. Excuse me. Sorry about that. With process-driven, we basically lay out everything that we're doing in the script, and it's totally abstracted from the code behind it. Now, what I mean by totally abstracted is that the code that drives a process-driven script does not have any information about the application. All the information, from the inputs to the objects, everything else is all contained in the data in the script. And here we have a format, which you've probably seen before, where we have 4 columns. The first column defines the screen or the window that you're dealing with. The second column is the controller, the object within that window. Then we have a mode, and that mode is really where the flexibility comes in. That mode can be an I for an input if you're placing data into a field. It can be a selection field if you're selecting from a particular drop-down list. It can be a V for validation. And then depending on what mode you put in, the data is the corresponding data for that mode. So instead of having so many different columns, we basically reuse the same 2 columns, mode and value, and data, to provide what we need for that particular step. In this case, you'll notice we have input for the first name, and then we have input for the password, input on the OK button, and then here we have a name, the same name object, and what we want to do is check if the focus is on that field. What's the focus? The focus is when the I-beam is sitting on that field. So if you start typing, you know that you're on that field. You know how when you go to websites, you type in the URL, and you start typing right away your username or password, and you see that there's nothing on the screen? Isn't that annoying? It's because the developer did not make sure that the focus was on that username field when you first get onto that site. So this is how you check for something like that. So here, we can check for an attribute, the attribute being the focus attribute. And what do we check for it to be either on or off? So again, it's not just data in terms of data to drive an application, it's also data to check an application. Process-driven framework is most complex to implement because everything has to be done external, so the routines have to be extremely generic. By being generic, they're extremely flexible in terms of what they can do. You have a high degree of both abstraction and encapsulation. You really have very little code to ever need to rewrite, et cetera, et cetera. So if we look at the different frameworks, we see here a table that kind of compares the benefits or not of each different one. Adding variations to existing scripts can be a low level of effort for all of them. Adapting changes to the application flow can be more difficult in the data-driven, more so on the keyword-driven, and less so on the process-driven. If we go down to the bottom of the list, the level of abstraction of the framework is lowest here and highest on the process-driven for all the reasons that we just stated. And complexity of implementation, again, low, medium, and high. But how about flexibility? So with complexity, you get all that flexibility. So you spend a lot of time doing it up front, but you get the flexibility down the line. So again, nothing's free in this world. Put the effort in up front, and then it comes out on the back end. So what are the things that a framework really needs to have? Reusability. You need to be able to run it time and time again to help you out. Flexibility. Maintainability. It should be easy to maintain it and update it. Scalability. You may have 50 or 100 or 200 tests. Well, that's nothing. An application of medium complexity could potentially require thousands of tests to be run. So what you need is a framework that can scale up to thousands of tests. Adaptability. Adaptability is, what is your application environment? What's the front end? Is it browser? Is it a client-server application? Do you still have some mainframe applications? So adaptability to those different environments is very important. And finally, extensibility. What does that mean? That means that when you need to add additional functionality, is there a place that you add additional functionality? Is it modular enough that it allows you to do that? Form follows function. Another saying from many, many years back. What I'm showing you right now, and I appreciate the clapping, is a picture from this document, which is the Test Automation Engineer Syllabus. Again, what I said, it was just released last week. The relevance of this document is that it kind of sums up nicely at least a part of, an important part of what this document is about, what we call the generic test automation architecture. The architecture is actually made up of 4 different layers. We have at the top, we have at the top the test generation layer, which includes your test models and manual test design. Then we have the test definition layer, which includes your test cases, your test data, your test libraries. Following that, we have the execution layer, which is what we traditionally think about as automation, your actual engine, and the execution, and both the logging of what the tests actually are producing through the engine, and also the reporting of the validity of whether or not those tests have passed or not. And finally, the adaptation layer. That's where we actually have the syncing up to the particular interface that your application has. On the bottom of that, we have automated framework. So the 3 last ones of those comprise the automated framework. The bookends are configuration management, test management, and then because automation is a development project of sorts, we have the project management at the top. That kind of sums up the vision for the different components that any automation solution should have. Does that mean that any solution has to have all of these components? Absolutely not. But this is something that is a good starting point to see what components you need to have in your automation solution. Now, I've been talking for many years about what I call essential functionality in a framework, and it sums up in these 4 words: input, navigate, synchronize, and validate. If there's nothing else you remember from this talk, please remember these 4 words. They are very critical in understanding the essence of what a good framework does and how it should be coded. So, when we talk about input, we're talking about not only putting data into a field such as a name field, we're also talking about selecting from a drop-down list, clicking on a radio button, selecting a checkbox, any kind of input that you do with respect to that application. When we're talking about navigation, whenever we test a system with any kind of interface, of course, you're always getting from point A to point B. So part of our testing should define how do we get from point A to point B. Is it through tabbing across the screen? Is it through mouse clicks? Is it through clicking on the tab of a particular multi-tabbed window? There's many different ways that you can actually get from one point to another, and it's important to understand that that is a type of data that you need to capture as part of your automated framework. Synchronization. When we test manually, we don't need to synchronize because our brains are smart enough to know that if the screen hasn't come up, we don't start typing on it. We wait for the screen to come up. With automation, so it doesn't get tripped up, we need to introduce these artificial things called synchronization points. Sometimes they happen automatically, sometimes you need to do them manually. Synchronization is very important because if automation doesn't have enough synchronization points, the automation will continue to run, the application is not at the right place, your script will stop. So much for that mountain vacation. Validation, on the other hand, is just making sure that the application is working the way it's supposed to be. So that if your application is a flight application, and what you're testing is that if I buy a first-class ticket and I put a promotional coupon, that I get a 20% discount. Is the value that's showing up 20% less than it should be? That's what we do when we do validation. Now, synchronization versus validation. A lot of times people think, well, those are both the same. The way I like to think about it is that synchronization ensures that we've arrived at the correct place so that validation can confirm the correct application behavior. Okay? Those are the 2 major differences there. Now, let's talk a little bit about objects or controls. Every object has a certain set of attributes, and many of the attributes are shared across different objects. Some of the attributes are specific to certain kinds of objects. What we want to do is understand what those attributes are and be able to control them. Common objects include a button, an input, select, or a text area that you can click on a browser. And common attributes for some of those objects will include whether or not that object is autofocus, if it's something that you can actually type into, the size of that object, The name, whether it's a required object or not, will let you move across that object if you haven't typed something in. The type of object that it is, and what the value, the current value of that object is displaying. So with functions, what you do is you create a function that's basically for that object. So you may have a particular function that's focused purely on input. So what you do is you create a function that says, okay, here's my input function, and you have a case statement that says, okay, depending on what type of object, is it a drop-down list, is it an edit box, is it a checkbox, you have a particular method or code that addresses that input function for that particular object. Once you do that for that object, then anytime that object appears anywhere in your application, your automated framework will just call that function once. You don't have to create that function time and time again. In the same way, we can have an object validation function to do the same thing, to validate across a variety of different objects. And object interrogation is basically what you need to know if you're looking for attributes. If you want to know if it's in focus, if you want to know what color it is, if you know what position it's in, you need to use an attribute function. You basically feed it, what parameters am I looking for, what attributes, here's the object name, go and find that information for me. Based on that, I know whether or not something's correct or not. So in addition to the core functions that I just talked about, we also need to have support functions to make a framework work. Those include things like capturing transition values. You may have a test that when that test finishes, you have incremental data that you need to store somewhere so that the next test can then pull that data, continue the processing along. There could be preconditions and postconditions that need to be defined. Debugging and logging is very important. You need to be able to have an audit trail of what exactly went on so that if the test looks like it ran okay, you can verify that there's actually no errors in the underlying code. Error handling and function libraries, etc. So, how do we survive in the world of automation frameworks? Well, first of all, you really need to make sure that your framework is abstract. And what I mean by that is, if the code has any reference to your application, if it hard codes the navigation or any data component, you've already started on the wrong foot. The code itself that you develop for your framework needs to be totally irrespective of what your application does. Everything should be defined outside. Excuse me. You need to identify the roles of the team. It's going to require some very technical people to implement the core functions, but you'll also be able to use folks that aren't so technical but who actually have some good domain knowledge to be able to define the data elements that you need to create quality tests. Pick the right project. Don't pick a project that's kind of on its way out. Don't pick a project that's barely started. Pick something that's well on its way, that's a critical project that needs to be tested on a regular basis. And focus on data. The tests themselves need to be purpose-built, have to have a single focus. The objects, you need to essentially figure out how many objects do I have, what types of objects, what classes are they, and have functions for each of those classes of objects that you have. The data for INSV needs to be defined. So much in the same way that you define input data that you would put into something, you need to define your navigation data so you can actually create a function that navigates from point A to point B. And very important, if you don't know this already, and it's been stressed on one of the Google blogs recently, avoid using logic in your automation framework. Any logic, by logic what I'm talking about is if your application has certain logic to create an end value of what it displays, do not try to replicate that in the automated framework, because there's a very high chance that you'll introduce errors into the automation in doing so. It's best to just figure out what those values are and then put the actual values as the expected result without actually creating the calculation inside of the framework itself. So for the framework to be successful, it needs to be abstracted. You need to have group participation at all levels. Very important not just to be technical and understand how to build it, you need to understand what you're testing. You can actually do test cases in advance if you already know the design of the application, you already know what objects are going to be there, you've already seen mock-ups of the screen layouts. Maintenance requirements, will be much less if you have a lot of abstraction, and it'll be highly adaptable for your future needs. So, final thoughts. Developing a framework, yes, it's possible. Just make sure you don't get ahead of yourself. If you have the right technical people, great. If not, you need to hire them or bring them in as consultants or whatever the case may be. Start small. Don't start very big. Start with a small pilot, do some lessons learned, figure out what works, what doesn't work, and you'll be off and running in no time. And remember, INSV, those are the 4 letters and the 4 words that you need to remember as you implement your framework.